Hey guys, so I'm going to be going over the second problem on the practice midterm number 1, I believe. Yeah, I think it's practice midterm number 1. The second problem on practice number 1, which is converting velocity versus time graphs into acceleration versus time and into position versus time. Okay, so let's just jump right in to make this video pretty short. Also, if you don't see me drawing straight lines, bear with me. The day I draw straight lines is the day that Microsoft stops discriminating against Apple products. Anyways, so the first thing I'm going to do is I'm going to go ahead and convert the velocity versus time graph into the acceleration versus time graph. And you're probably wondering why I have this weird art piece drawn here on the y-axis of the acceleration graph. And I just wanted to draw that to show you guys that the values on the y-axis for acceleration, right, aka the value of the acceleration, is the slope of the velocity at any given point in time, right? So the higher acceleration values refer to more slopey regions, and then and vice versa for the negative part. So a really, really big negative acceleration just means a really, really downward sloping slope. And a value of 0 means a horizontal piece. And we can see a couple of horizontal pieces in this problem. So let's go ahead and just start on that really quick. So in the beginning, let's try to analyze what's happening. So in the beginning, what can we tell about the behavior of this velocity graph? And again, this is a very important note. The acceleration only tells you about the behavior of the velocity graph. It tells you nothing about where it started, how it started, where it started or where it ended. It only tells you how it started, how it ended, and what was happening throughout that entire time, right? So let's look at the beginning. Let's see what's happening. We have this point. And if you take the infinitely small slope here, you see that it's a straight line roughly going straight out. And as you go up, you can see that if I take the tangent line, it gets a little bit slopier. And if I keep going, I get even more slopey. And then over here, it actually looks like I'm at probably one of the slopiest points. Let me redraw that a little bit better. I'm at probably one of the slopiest points. At least it looks like that. And then again, as time goes by, I get less and less slopey. And then at the end, I have this similar pattern as over here, where it's basically 0. So if I wanted to try and draw this on an acceleration graph, I'd go, okay, so in the beginning, it looks like I'm basically at 0 acceleration. I'm not really moving. Okay, so let's say I'm around here somewhere. Cool. Then I get slopier and slopier. So what does this line look like relative to the ones I drew? It looks something like, let's say maybe this one, right? So the next point, like the next second, let's say I'm around here. At the next point, it looks a little bit more like, let's say this one, right? And you can probably see the pattern already. It's getting slopier and slopier until about this point. I don't know, we can call this point time max slopey or something. Time max slopey. I don't know what the hell that writing is, but whatever. So we get to max slopiness, let's say around, I don't know, that time period right there. So it looks like our acceleration looks like this. Then what's happening, once we get to that max slopiness, again, on the y-axis, this is the degree of slopiness. Once we get to that max slopiness, it looks like we get less and less steep over time, so less and less slopey. And eventually we go back to 0. So it looks like our behavior after that time period looks something like this. And you get a nice V shape. And again, if you guys notice in the solutions, these lines didn't necessarily have to be straight lines. They could have been like this or maybe like that. You can't necessarily say just by looking at this graph. But for this class, of course, just straight lines going down would suffice. That would work perfectly fine. Now let's go ahead and go over to the position versus time graph. This is probably the trickiest part. I'll be honest, this is probably the trickiest part. It's a little bit hard going backwards from velocity to position. So let's try our best to go through it slowly. What do these values represent? So when it says that we start off here, what does that mean? Let's say this was like -10, right, or something. -10. Just like how acceleration was the slope of the velocity is the slope of the position graph. So down here, we're pretty slopey in the negative direction, right? So we have a negative slope that looks something along the lines of this. Like one of these right here. And probably it looks a little bit like this one right over here. And then over time, we get less and less slopey. Let's say that's, I don't know, 4. Don't mind my scaling. And then we're at 0. And then again, 4, let's say 10, right? These are all positive. These are all negative. So in the beginning, we have a really slopey behavior of the position graph, right? So it looks very slopey like this. Then we get less and less slopey, right? But still negative slope. So we get less and less slopey, but still negative slope. And then over here at one exact point in particular, our slope is actually a straight line like that. It's 0. Again, the velocity is the slope of our position, right? So the slope is right here. I'm drawing the slopes in, and that's corresponding to our values for our velocity. And then the exact same behavior happens in the reflected side, right? In the positive side. So this should have that similar behavior. So over time, it gets more and more slopey. So right now we're at 0 slopiness. Then we get slightly more slopey. Then slightly more, and then again, more as we go. So our position versus time graph should look like this. I can't draw straight lines. It should look like this or something like this, okay? All right, cool. So I'm gonna go ahead and move on to the next problem. I'm actually gonna skip case B. I'm gonna skip case B only because it's very, very similar to this with a very, very minor difference, okay? In the position versus time. Actually, no, I take that back. The acceleration graph is quite different. So I'm gonna draw this one anyways. Let's draw the acceleration graph. Oh my God, these straight lines. There we go. I'm going to draw the acceleration graph right here. Okay, so let's try and analyze what's happening to our acceleration in this case. I'm going to redraw those things again just a little bit for dramatic purposes. Less slopey, more slopey, more, and then even more as you go down. Okay, so in the beginning, what kind of slopiness do we have? In the previous one, it was pretty dead. It was just pretty straight. You know, it was a 0 slopeness almost. In this case, it looks like we're actually quite slopey in the beginning. So let's say that's our tangent line. And what's happening over time? Again, it's telling us the behavior of our acceleration is telling us the behavior of our velocity graph. Looks like we're getting less and less slopey. And then over here, it looks like it's the smallest slope. And then we start picking up our slope again. It gets slopier and slopier again. And then over here at the end, it's quite slopey. So in the beginning, we have some fairly high positive slope, as you can tell from the positive slopiness of it. It's pretty positive. Then we get less and less slopey till about this point right here. At this point, it looks like it's our smallest slope. But notice how it's still not 0. So again, it's going to look something like this. Draw that better. It's going to look something like this. But notice how a lot of students actually did this in the beginning. They went down to 0 and then went back up. That would actually be technically incorrect, only because the acceleration never hits 0, because if it's for it to hit 0, you'd have to have some horizontal line. And this graph actually has no horizontal lines. So to properly draw this graph, it should look something along the lines of this. And for the sake of time, I'm not going to redraw the position versus time graph, but it's going to look something like this. And if you want to go back for the reasoning regarding this, it's going to have a very similar reasoning for case B. Now, case C, I'm also going to skip only because it's very similar to case A. It's simply the mirrored image of case A. Okay, so again, I'll let you guys think about that one. And then let's do part D. Now this one's a fun one. Let me redraw the acceleration versus time graph, and I'll try and speed these parts up just so
we don't waste time watching me draw straight lines. Okay, so this is the acceleration, and this is the time. Now again, let's ask ourselves the slopiness behavior.
Right, so this is the behavior again. So let's look. In the beginning, what's our slopiness like? Again, it looks pretty flat. It looks pretty flat. Then it looks like it's getting more slopey. Then it's getting more slopey. And then again, more slopey. But then here's where it takes a very weird turn. This one gets kind of confusing. If you look very closely, at exactly this point, it's quite slopey in the positive direction, right? But then almost like an infinitely small period of time later, you're immediately in a really steep negative slope. So that's a very weird behavior going on. So let's see if we can model it in our acceleration versus time graph. So in the beginning, again, we're at 0. So let's say we're somewhere here. And are we getting more and more slopey? Well, it looks like it. It looks like we're getting more and more slopey over time until we get to this like peak slopiness. So it looks like we're going up and up in slopiness up till, let's say, I don't know, some arbitrary point like this. And then it's really interesting because we immediately go to the super slopey negative slope, right? And then again from there, it slowly starts to decrease in slopiness till it gets to about 0 again. So it looks like we get to a very, very negative slopiness again. So we jump straight down into a negative slope. Then we again creep back up to 0, as you can see from this last part. So our graph should look something like this. And whether you have a straight line over here or if it's just a jump, if it's just empty right here like this, white, I don't think it really matters that much. But for this class, I'd suggest keeping your lines continuous. So don't do any jumps, just draw a straight line down. Okay, and then let's do the same thing for part E. Actually, let me finish the position versus time graph.
So let's draw our position versus time graph. This is position. Okay.
So judging from our velocity, what does our position versus time graph look like? Let's erase this again. Okay, so what is the behavior of our position graph? Don't forget that velocity describes the behavior of our position graph. Okay, I have to always say that slowly just so I don't mess myself up. But yeah, velocity describes the behavior of the position graph. So what's the behavior of this graph over here? Well, it looks like, again, let's put some arbitrary numbers like -10 over here, right, for our velocity. And then like, let's say -4 here, and then let's say 0 right there. So it looks like we're starting off pretty slopey in the negative direction. So we have a pretty slopey negative behavior. So it looks like this, pretty slopey. But then it's getting less and less negatively slopey. So it's going like this. It's getting less and less slopey as time goes by. And then it gets to 0 eventually. So again, we're getting less and less slopey as our value gets smaller until we get to about 0, which is like a flat line. So we get to like about right there. Let me actually shift this over a little bit just to give myself some more room. Hint, hint, notice how I'm shifting and it doesn't matter because, again, the velocity graph only tells us about the behavior of the graph and nothing about where it starts or where it ends. So anyways, so we end up at 0 here, right? So at this point right here is this point. Then we start getting a very, very small negative value. And then that negative value again increases back up to 10. So a small negative slope would look like this, right? Then a bigger slope would look like this. And an even bigger slope would look like this. And then it levels off at a really, really big negative slope. So our final answer should look something like this. I can't draw those straight lines. Should look something like this. Okay, so this is what our final answer should look something like. The solutions are much, much prettier and they're much better, so take a look at those. And then this one has a very, very similar behavior. I'm gonna draw...
Really fast, I'll fast forward this part. Acceleration in the x direction versus time.
This one should look like what? In the beginning, it's again 0. So it's 0 over here. So we're at 0 again. Cool. Then we get an immediately small negative slope. Then a slightly bigger negative slope. Then a slightly bigger negative slope. And then a huge negative slope. Then we jump straight to positive slopes. That gets smaller over time. Okay? So we're going to bigger and bigger and bigger and bigger and bigger negative slopes. It jumps up to a really, really large positive slope. Then that slowly dies off as well into this sort of shape. And then lastly, if we want to draw the position versus time graph, this is x, this is t. If we want to draw our position versus time graph, let me erase this, clean it up a bit. If we want to draw our position graph, let's ask ourselves what's happening in the beginning. Well, in the beginning, we have some pretty big positive slope. It's pretty big. It's like, again, let's say plus 10. I love how I'm using 10, 4, and 0 every single time. Say it's like plus 10. Cool, so it's pretty slopey in the beginning. Let me redraw this down here, actually. And it's nice that I keep redrawing it, I think, because it kind of proves that it really doesn't matter where I start for my position graph. So we start off pretty slopey, and it gets less and less slopey over time because our value gets smaller and smaller and approaches 0 over here. So we're getting less and less slopey, less slopey, less slopey. We get to 0 roughly. Then it starts, again, picking up in slopiness, right? As this value gets bigger and bigger and bigger, it gets more and more slopey. So it was 0 over here, 0. Then it got slightly more slopey, then slightly more, and then slightly more. And then at, I guess, peak slopiness over here. So our final answer should look something like this for our position versus time graph. Boom. And there you have it. You have the acceleration and the position versus time graphs for those four. And I'll maybe add this in at the end of this video just to illustrate it, but it really, I'll let you guys practice that one on your own, okay? And then just to take a look at the solutions. It's the exact same sort of thing as over here, okay? So try and do that one by yourself, guys. And yeah, thanks for watching. I'll try and make better videos in the future. This one was kind of made last minute. And yeah, I hope that helped. And good luck on studying for the midterm.